LINEST. The LINEST function calculates the statistics for a line by using the least square method to calculate a straight line that best fits your data, and then returns an array that describes the line. We will use an example on simple linear regression. Here's this example, simple linear regression. We'll copy this and use this in our spreadsheet. So we have the month column and the sales column, just as we have the month column and the sales column. So the month and the sales column. We'll insert the chart. Use scatter chart. Insert chart, and we'll use scatter chart. And insert a trend line, linear, a linear trend line, and use the equation as label and show the R squared. So here's the equation, the trend line equation, which is sales equals 1000 plus 1000x plus 2000, and R squared is 0.934. So we calculate this using LINEST. So this is LINEST, data y, known y's, and known x values, enter. So our y-intercept is 2000, matches to our trend line equation, and the slope, 1000, matches to our trend line equation. We can calculate slope using the slope function. Data, that is our known data y and known data x. 1000 matches to our LINEST output and our trend line. The intercept, we use intercept function, data y and data x. And we still get 2000, which is the y-intercept, matches to our LINEST output and our trend line equation. We can use the matrix solution. First, we fill up the 1 comma x matrix. So 1 and the x values are a formula of the x values. And then we enter the P Jorina inverse. So it is equal to minverse and mult transpose of the 1 comma x matrix and itself. And we calculate the P Jorina vector or P Jorina cofactor, which is m mult transpose of the 1 comma x matrix and the y values. This is the y values. Now we can calculate the coefficient. So it is m mult of the P Jorina inverse and P Jorina cofactor or vector. So 2000, which is the intercept, matches to our intercept formula and LINEST output. 1000, which is m, matches to our slope function and our LINEST output and our trend line. Next, we calculate the rest. So we change this to true or 1. 1 comma 1 to show the full statistics. Here we have the R squared, 0.9338 rounded up as 0.934. We can calculate R squared by using the function RSQ. Data y, no data y, and data x. That is 0.9338 matches to our LINEST output rounded up as 0.934 in our trend line. This is also the stay x. We can use stay x. So this is the standard error of the y estimate. Stay x, data y, and data x. 5 556.77 matches to our LINEST output. Next, we calculate for the standard error values of the slope and the intercept. We start with the intercept. So this is equal to stay x. Now this is the stay x times square root of p Jarina 1. 518.33 matches to our Linus output. Here we have also stay x times square root of p Jarina 2. And this matches to our Linus output. Now we can calculate for the rows, starting with it is rows minus columns. So rows of the 1 comma x matrix minus columns of the 1 comma x matrix. So our degrees of freedom is 4, and it matches to our Linus output. And next we calculate for the residual sum of square, which is equal to degrees of freedom times stay x squared to the power 2. And this matches to our Linus output. Next, we calculate for the regression sum of squares, which is equal to r squared times the rows of the 1 comma x matrix times variance of the population y. And this matches to our Linus output. Next, we calculate for the f statistics, which is equal to regression sum of squares divided by degree of freedom of the numerator, and which is 1 because we only have one. There's only one x or independent variable. There's only one. And divided by stay x squared. Stay x to the power 2. 56.45 matches to our Linus output. And this completes a simple linear regression using LINEST.